Okay, back here. We're going to get started again. I'm going to talk about problem solving using dimensional analysis. Dimensional analysis is by far the most common tool that we use for solving problems in chemistry. We could, what we have is basically the setup goes like this. Draw it out here. Oh, that came out wrong, but it's all right. You're given, given a quantity and a unit, and then what we do is we use conversion factors. Conversion factors. Conversion factors are anything that relates two or more things. And so an example of a conversion factor would be like they're exactly 1,000 milliliters per liter, or in 1 liter, there's 1,000 milliliters. And so this just comes from the equivalent, that 1 liter is defined as 1,000 milliliters. And so there are two ways of using this relationship here. This one converts liters into milliliters. This one converts milliliters into liters. And so we have one or more conversion factors, one or more. Sometimes we have lots, just keep adding them until we get to the desired. And so sometimes there's no strategy, there are different things. Like, let's say you're traveling through a jungle and there's some trails in the jungle and lots of paths and lots of forks, Which direction do you go in the jungle, And so let's say you're walking along a path and you don't know, you reach a fork. Do you go left or do you go right here? Sometimes you just try both, Sometimes if you go left fork and it dead ends, then you go back and then you try the right fork. So this is the methodology. Once you get more familiar with the jungle, then you kind of know which way to go. So you reach this fork, oh, I know to go to the right here. But that comes with familiarity, and familiarity comes with practice, doing more and more of these problems. And so what we do is we just do trial and error. If one way doesn't work, go back and try the other way. That's my strategy. And so there's really no strategy here. When I'm given a problem, it's like going through the jungle. I just do it step by step. So I'll do one conversion factor and then do another and then another and another until I get to the desired. Sometimes I go the wrong way. So maybe this way dead ends. And so then I go a different route with a different set of conversion factors, if that dead ends. And so that's the strategy that I use here. The conversions can be simple. Like we did a couple of simpler conversions earlier. Now the conversions can be more complex. And so we'll look at that. When we do some of these, let's see. Come on. I'm going to clear this. All right. All right. So here's some more measurement practice. Thermometers, in this case, the resolution didn't come out. Yours should have come out better, but mercury hates glass. And so mercury has a convex meniscus rather than a concave. So for mercury, we measure at the peak. the top of the hill. That's one difference. And so for water, water loves glass, and so water climbs up the glass. Mercury hates glass, and Mercury tries to avoid all contact with the glass. And so you see these are little convex. They curve up rather than curve down. So we measure at the very top for Mercury. We measure at the very bottom for water. This is all from the supplement. And so this is how they're estimating the digits here. You can read through that. And some practice. This isn't such a good copy because the scanner resolution wasn't so great. Here's measuring inches. Measuring millimeters and centimeters is easy, but when we measure inches, how do we deal with uncertainty there? I do a little bit differently than your book does it. Yeah. And so let's look at this one, for example. So when I look at the inch scale here, it's not so easy. Like here we have it in tens. You know, here it's a bit more more difficult to measure. But still, it's not bad. Let's take a look at this measurement here. Okay, this is measuring in sixteenths. So this is 1, and this will be 1/16, 2/16, 3/16, 4, 5, 6, 7, 8. 8/16 is halfway. 9/16, 10/16, 7, 11, 12, 13, 14, 15, 16/16. So this has fairly high precision. A lot of rulers measure to the nearest eighth, you know, 1/8, 2/8, 3/8, 4/8 to be a half, 5/8, 6/8 is 3/4, 7/8, 8/8, which is 2. And some even go higher precision, 30 seconds, you know, so it'll be 32 lines. But in this case, we have 16 lines, so it's 1/16 inch precision for this. Okay, now there's no uncertainty here on 1. And so there's no uncertainty here. And then it's 1, so we say 1 and how many sixteenths? So it looks like 1, 2, 3, 4, 5, 5/16. There's no uncertainty there, here. It's definitely 5/16. But it's between 5/16 and 6/16. So when I look at that, that's not halfway. Halfway would be about there. So I'm looking, what would you call that? Would you call that 5? Let's see, 5.5 would be halfway. So I'd call that 5.4/16. Are you guys seeing that too? 5.4/16? Yes, okay. So I get this measurement as 1 inch is exact. This is exact. 5 there's no uncertainty, that's exact. But the 0.4 is uncertain. And so what we do is it's going to be 1 plus 5.4/16 inches. This double line means inches. And so what is 5.4/16 in decimal form? So what I'll do is I'll do 5.4 divided by 16 on the calculator and convert that to decimal form. So that comes out to okay, this is going to be 1 plus, I'll do it in steps. This is going to be 1 plus 0.3375. Well, I'm only allowed, this is division, so I'm only allowed 2 sig figs here. And so I'm going to write this as 1.33 and then subscript this. This 7.5 is not significant. And so this is going to be 1.34 inches is the measurement here. And so in other words, 1 and 5.4/16 is 1.34 inches. And so with the inch scale, we have to do a little more work to get that to work out. The same thing goes. Let's say, you know, what's your height? Let's say my height is, my height is 5 feet, 10 inches, let's say. That's my height. And so how many centimeters is that? So how many centimeters that is, this is a combination of algebra and dimensional analysis. This is algebra plus dimensional analysis in terms of analyzing the problem solving method. And so the first thing I want to do is I want to get it in terms of either feet or inches. It doesn't really matter which one. Maybe I'll do it in terms of feet, inches. That might be better. So how many inches is 5 feet? Well, it's 5 times 12, that's 60 inches. 60 inches plus 10 inches, that's going to be 70 inches. 70 inches. 70 inches is how many centimeters? Now it's going to come the dimensional analysis part. So I have 70 centimeters, and then I know this. I know that in exactly 1 inch, there's exactly 2.54 centimeters. This is an exact conversion factor. Exact conversion factors, we should know all of them. So I know this one, memorized it. And so that's going to be 70 divided by 2.54. Oops, what am I doing? 70, sorry, I'm doing this wrong. It's 70 inches, not 70 centimeters. Sorry. Let me redo that. So I'm 70 inches tall. And then it's 2.54 centimeters per inch. And so this is dimensional analysis. We look at the dimensions, which are the units. Inches cancel out inches, that leaves us with centimeters. And so that's 70 times 2.54, which means I am at 177.8. 177.8. Now, how many sig figs am I allowed? Well, it depends if I call that 2 sig figs. Maybe, you know, if this were 2 sig figs, then I would have to go to 180 centimeters, something like that. You know, that would be 2 sig figs because 180, this 0 could be, or it doesn't necessarily have to be significant there. Or 1.8 times 10 squared centimeters, which would be proper there. This happens when we're mixing up English units and metric units. English units and metric units get screwed up all the time. 70 is not exact, right? 70 is not exact. 5 feet, 60 is exact because I'm definitely taller than 5 feet. But the 10 inches is not exact. And so when I add these, I get 70. And so that ends up as being 2 sig figs, right? We have the same problem with pounds and ounces, unfortunately. We have to do the exact same type of thing when we're dealing with pounds and ounces. And so let me do that here as just a quick example. This is actually a problem in your book. You should take a look at the problem in your book. Well, actually, it's going to take too much time to dig through your book and find it. Let's say something weighs 5 pounds, 6 ounces. 5 pounds, 6 ounces. How many grams is that? How many grams? 5 pounds, 6 ounces. Or how many kilograms? Or how many kilograms? And so again, we have this composite unit, pounds and ounces. This is a composite, 2 different units here, 2 different dimensions. So we got to get in terms of either ounces or in terms of pounds. It doesn't matter either way, but I'm going to go in terms of pounds because ounces I'm not as familiar with. And so this is going to be 5 pounds plus, okay, 6 ounces. Here I'm going to use dimensional analysis to do it. I know that there is in exactly 1 pound, there's exactly 16 ounces in 1 pound. And so the ounces cancel out. And that tells me how many pounds I have. 6 ounces. 6 divided by 16 is 3/8, which is 0.375. So this is plus 0.375 pounds. And so this is 5 pounds. And so this is going to equal 5.3. Well, how many sig figs am I allowed? Well, it looks like I'm only allowed 1 sig fig here, so I'll subscript this. So 5.375 pounds. Well, how many grams is that? Well, what I'm going to do is I'm going to multiply that by this. I know that in exactly 1 pound, I have 453.6 grams approximately to 4 sig figs. And so the pounds cancel out. It tells me how many grams times, 1 plus 5. Okay, times 453.6. 2,438.1 grams. Well, I can also do this. I can convert this into kilograms. This is the incorrect number of sig figs. So if I only have 2 sig figs, this is going to be 2,400 grams. And then over here, I can convert it to kilograms. 1 kilogram is exactly 1,000 grams. So the grams cancel and gives me kilograms. And that's going to be 2.4381 kilograms, which is going to just be 2.4 kilograms, according to the sig figs that I have here. Okay. That's wrong. Is that right? Oh, no, that sounds right, I guess. So English units are a bit complicated because we have composite units like that. Sometimes we deal with composite units a little differently. Let me show you a problem where we have a composite unit that we deal with a little bit differently here. Sometimes the units are a little strange as well. And I'm going to go to the book. Except I'm not going to go to our book. I'm going to go to a different book here. Okay. I know what I'm doing. Here's another example of composite unit where we have 2 different units in the same measurement, but it's different than the last 2 examples we had was pounds plus ounces or feet plus inches. This composite unit is a little bit different because this composite unit is going to be square feet times meters, So 2 of the lengths are in feet, 1 of the lengths is in meters, that kind of deal. And so it's a little bit different composite unit than what we just saw. And so this is it here. Acre times feet, Acre is a unit of volume here. Acre And feet is a unit of length. And so if we take volume, not volume, area, acres area times height or length or whatever is going to give us volume. So acre feet is a unit of volume. So it's a composite unit. It's an acre times a foot. Oh, an acre, 600, this is the definition, 640 acres is exactly 1 square mile. And so, and a mile is 5,280 feet. And so let's take a look at this problem. This is from the Chem 1A book. But just to give you an idea of different types of composite units, let's take a look at this one. In the United States, the volume of irrigation water is usually expressed in acre feet. That's an acre times a foot. Again, acre is area, foot is height, this is volume. 1 acre foot is a volume of water sufficient to cover 1 acre of land to a depth of 1 foot. So if I have an acre foot of water, take an acre of land and bury it in 1 foot of water. 640 acres is defined as 1 square mile. 1 square mile is 1 mile is 5,280 feet. The principal lake in the California Water Project is Lake Oroville, whose water storage capacity is listed as 3.54 times 10 to the 6 acre feet. So 3.54 million acre feet. Express the volume of Lake Oroville in cubic feet, cubic meters and US gallons. Okay, and so there's some information. When we do this, I see this is a conversion factor here. It relates two things. And so I could either convert from acres into miles squared or miles squared into acres. This is another conversion factor here. So I can convert from miles to feet or feet to miles, either way. And so I see two conversion factors here. This is a given here. This is how much I have. And I can't, I can't really change that. That's what I got. And so how would I do this particular problem here? And so let's go ahead and do that. All right. So the volume is has a weird composite unit. It's 3.54 million, or 3.54 times 10 to the 6 acre feet. Feet, like that. And so this is what we're given. And what we're going to do is we're going to use dimensional analysis to solve this. Oh, actually, I guess you guys can't see this, can you? Okay, can you guys see this? Yeah, okay, great. Okay, so dimensional analysis, this is what we try to do in dimensional analysis. Option 1, we try to get rid of acre and feet. We try to get rid of both of those, knock them out. If we can't get rid of both of those, then we'll try to get rid of one of those. So option 2, let's try to get rid of acres. Cross out the acres, we'll be left with feet. Or option 3, we'll try to get rid of the feet and leave the acres. Okay, then we look for a relationship between acre, feet, and something else, or feet and something else. So for example, here we can go from feet to inches, or feet to miles, or whatever. There's nothing that takes acre feet here. And so what are our options here? If we want to get rid of acres, then there was one option. There are 640 acres in 1 square mile. And so this would work. I could get rid of acres and convert it into square miles. So I'd have square miles times feet. Square miles is area, feet is height, and then that's volume. Or I could get rid of feet. So for example, I could go to 12 inches is 1 foot, or I could go to 1 mile is 5,280 feet, or are there any others? Or, yeah, there are others, but I don't know. That's about it. Which one do you want to go with? Option 1, where we give up? Option 2, where we can get rid of acres? Or option 3, where we can get rid of feet and convert it into inches, or feet converted into miles? Which one do you want to go for? Now we're in the jungle. We're in the jungle, and we don't know which path should we take. Should we take path 1, 2, or 3? And let's see, option 3. That could be fine. We could take option 3 and see where it leads. Unfortunately, option 3 leads to a dead end, and we're going to run out of options. And then we backtrack, and then we say, okay, if option 3 dead ended, maybe option 2 works. And so we're going to try option 2 here. And so if we go with option 2, this is what's going to happen here. So let's get rid of option 1, which is, and we're going to get rid of option 3 because we attempted it and it failed. Now we're going to go to option 2. So acres will cancel out acres. So I have acres there. And then I'm left with miles squared times feet. Well, I don't want miles squared times feet. I want cubic feet. Well, I know the relationship between miles and feet, you know, so I could use that. And so now we're going to go to the next step. The next step is I want to get rid of miles squared if possible. And so can I get rid of miles squared? That would be the best, but I don't know anything with miles squared. Maybe I could get rid of miles. Yeah, I could get rid of miles. If I get rid of this squared thing here, then I know that there are 5,280 feet per 1 mile. So in exactly 1 mile, we have, actually this turns out to be by definition, we have exactly 5,280 feet. But that only gets rid of one of these. I need to get rid of 2 of them. In other words, I need to get rid of the squared. So there are 2 options. I can just tag another one on there. That's option 1. Or option 2 is this is what we're going to do. Okay, this is not working for some reason. My mouse is, All right. So this is what we're going to do. We're going to take this one and then square the whole thing. If we do that, so this is what we're going to end up with. If we do that, then this one is going to end up as this. It's going to end up as 5,280 squared, foot squared, divided by 1 squared, miles squared. And so now I have the relationship between square miles and square feet. And so let's write this all over again. 3.54 times 10 to the 6 acre feet. And then we got rid of the acres in the first conversion and converted that to miles squared. 640 acres. So the acres canceled. So we got miles squared times feet. Now we're going to get rid of the miles squared. And so they're 5,280 squared feet squared per 1 squared miles squared. And so now the miles squared cancels, and that leaves me with foot squared. Well, foot squared times foot is foot cubed. And that's what I want. So I'm done. I need foot cubed, cubic feet. And so let's go ahead and do the calculation here. When I do the calculation, I got 3.54 times 10 to the 6 divided by 640 times 5,280 squared. And so this comes out to 1.5, let me sig figs 3, 1.542 times 10 to the 11 cubic feet. And so Lake Oroville has 1.54 times 10 to the 11th cubic feet. Or I'd like to do this by 9, so this 10(9), which is equal to 154 billion cubic feet. Well, how many cubic meters is that? That's the next question. So this is part A. Well, we have cubic feet here, and so we want cubic meters. So part B would be cubic meters. So it's the same thing, except it looks like we're going to have to do more steps. 3.54 times 10 to the 6 acre feet. And then get rid of acres. And then get rid of miles squared. Okay, now we're at feet. And so how can we get to meters? What's the relationship between feet and meters? And so this is the way I would do it here. What is the 2 for? Counselor, which 2 are you referring to? Oh, my eraser's not working, shoot. All right. Okay, so now I have acres canceled. I have foot times square foot is cubic feet. And so what I'm gonna do here is I'm gonna go from feet, let me tell you what I'll do. I'm gonna go from feet to inches. And then what I'm gonna do here is I'm gonna cube it because I need to get rid of cubic feet. Do you see that? And then let's continue this on here. Oh, I think that is a 2. Where are you guys seeing it? Well, anyway, you can unmute yourself if you like. And the reason I have to cube it is because now we have foot times square foot is foot cubed. So I need to get rid of the foot cube. Now I get cubic inches. And then from cubic inches, I can easily get to centimeters because I know that 1 inch contains exactly 2.54 centimeters. And then I'm going to cube this whole thing because I need to get rid of cubic inches. So I'll cube the whole thing. And then times. And so what happens is foot times foot squared is foot cubed. That cancels the foot cubed here. Cubic inches, cancel the cubic inches here. That gives me cubic centimeters. And then I'm going to go to meters. Well, the relationship between centimeters and meters is in 1 meter, there's exactly 100 centimeters. And then I need to cube the whole thing. So this gives me the relationship between cubic meters and cubic centimeters. And now I'm done. I'm where I'm at, want to be at, which is cubic meters. And so the units work out. This is dimensions of the units. And so I'm just going to continue on here, times 12 cubed times 2.54 cubed divided by 100 cubed. So how many is that? 3, 6, 9, 4.3 billion. 4.366 billion cubic meters, or times 10 to the 9th. And so I'm allowed 4.37 billion cubic meters. That's it. Okay, let's do one more here. The last part of this is gallons. How many gallons is this? And so let me show you how to do the gallons here next. Let me clear this. US gallons here. So we did part A, cubic feet, part B, cubic meters. Now we're going to do US gallons. So this is, I'm guiding you through this, you know, because you haven't done this probably before. So let me guide you through this 3.54 times 10 to the 6. Let me go back to the whiteboard. Which is up here. So just start the problem over. Let's get rid of acres. 640 acres. This is given per square mile. I'll use this with square miles times foot. And then I'm going to go from miles to feet. 5,280 feet per 1 mile. Sorry, I don't know why my eraser is not working here. Let's see, erase. Forget it. Thought it was maybe the window or something. But this is miles squared. This is linear miles. And so again, I have to square the whole thing. This 2 comes from the fact that this is miles squared. This is miles. This is not true. 5,280 square feet is not equal to 1 square mile. This is not true. What is true is 5,280 foot squared is equal to 1 square mile, because we square everything. If we square everything, then the equivalency is still okay. So this is where that 2 came from here. The 2 came from that. Okay, now if we have miles squared canceling miles squared, then I have feet squared times feet. So I have cubic feet. Foot squared times a foot is cubic foot. Okay, but I don't know the relationship between feet. I can go feet to inches, that's easy. 12 inches in 1 foot. And then what I'm gonna do here is I'm gonna cube it now rather than square it, because now I have cubic feet I need to cancel. So this foot and that foot squared is a cubic foot, and that cancels. Now I have cubic inches. If I have cubic inches, then what I'm gonna do here is I'm gonna go to centimeters here. And I'll tell you why I'm gonna go to centimeters, because I know something about centimeters. This is gonna be cubic inches, so I need to cancel out with cubic inches here. And that leaves me with cubic centimeters. Well, I know something about cubic centimeters. 1 cubic centimeter is the same thing as 1 milliliter. And so I don't have to cube this, because this is already cubed here. And I don't know what a milliliter cubed is. It's just 1 milliliter is equivalent to 1 cubic centimeter. So the cubic centimeters cancel out there. And then I know that in 1 liter, I have 1,000 milliliters. And then I know that I just learned this to 4 sig figs. To 4 sig figs, 1 gallon is equivalent to 3.785 liters. That's the one we looked at earlier. The liters cancel out. That leaves me with gallons. So how many gallons? So I'm done. Do you see I had to string together a bunch of these, and sometimes I go the wrong way, you know, and screw things up. But the units or the dimensions work out. So let's go 3.54 times 10 to the 6 divided by 640 times 5,280 squared. Okay, 5,280 squared, I'm going to set equals here, times 12 cubed equals times 2.54 cubed equals divided by 1,000 divided by 3.785. And I get 1.1 trillion gallons, 1.153 times 10 to the 12 gallons. So it's 3 sig figs, so 1.15 trillion gallons of water, lake water. Excuse me. So we did a couple of things here. One, we had a composite unit, but this was multiplied rather than added, like in the previous examples, pounds and ounces. And then we had to use nonlinear conversion factors. That is, we had to square some of these and we had to cube some of these. When we square and cube, we have to cube everything in there, or square everything, you know, inside the parentheses, and then it works. So let's go back to our here we are. Let's go back to the supplement here. Take a look. Some more measurement problems. Okay. Well, they got rid of some of the calculations in this version. I didn't realize they got rid of. There were some squared and cube conversion factors. Oh, here they are. Maybe they didn't get rid of it. Rotate that clockwise. Yeah. So here's one where you have to do this. The funny stuff that we just did. This one. You know, so we're going to go from foot squared. We can go foot squared to, let's say, inches. But this one, we're going to have to square it, everything. And so the conversion factor that we use to convert square feet into square inches is this. They're 12 inches in 1 foot. And so if we square this whole thing, then what that says is that there are 144 square inches in every square foot. Okay. And so we'd use that, or we could just do 12 squared, it's fine. And then from inches squared, we go to centimeters squared. Well, to do that, well, we're going to need another conversion factor. And so we know that they're 2.54 centimeters for every inch. But this is linear, so what we have to do is we have to square the whole thing. So it turns out there's 2.54 squared centimeters squared per 1 squared inch squared. That'll take us to centimeters. And then we go to millimeters. To go to millimeters, there are 10 millimeters in a centimeter. 10 millimeters per centimeter. But again, this is squared, so we're going to have to square the whole thing. This one's easy. 10 squared is 100. So it turns out there are 100 millimeters squared for every 1 centimeter squared. And eventually that takes us to where we want, which is square millimeters. So we have to do the squaring stuff for this one. We have to do cubing stuff for this one. This is a cubed. So we got to do some cubing stuff to get to liters eventually. What else do we have here? This one we have to do some cubing stuff. Here we got to go from inches cubed to centimeters cubed. It's only one step, but we have to cube it. What else we got here? Again, this is a cube. So we got some squaring and cubing business we got to do in the supplement here. And so these are supplemental math problems of math 1. Supplement. All right, the next thing is this that I want to to talk about problem solving. When we do conversion factors, you have to be very detailed in your labeling. It's very tricky sometimes. I'm gonna show you by doing a difficult problem here on what I mean by this. I don't think I have enough time. Well, at least we'll get started on it. We have to be very careful about how we label things like this here. So let's talk about this particular problem. The volume of seawater on Earth is about 330 million cubic miles. If seawater is 3.5% sodium chloride by mass, so what is this percent by mass? So percent by mass. Let's talk about that next here. Percent means part per 100. And so if we have 3.5%, what that means is we have 3.5 parts per 100 parts. Now, the critical thing in working with this type of stuff is what are the parts? We have to be very specific as to what the parts are. And so it says seawater is 3.5% salt, sodium chloride by mass. Sodium chloride, okay, by mass. And so what that means is we have 3.5 mass. We most commonly use grams. It doesn't matter what mass we use, but we'll use grams. Sodium chloride has a formula NaCl. Most people know that already. Okay, if seawater is 3.5%, okay, so that's 3.5 grams of sodium chloride for every 100 grams of what? In this case, it's for every 100 grams of seawater. So if you take 100 grams of seawater, there's going to be 3.5 grams of that will be sodium chloride, and 96.5 grams will be water and other stuff. And so that's what we have by mass. We could use any units here. It could be 3.5 pounds. If I had 100 pounds of seawater, I'd have 3.5 pounds of sodium chloride. Scales that way. And has a density. Okay, what is the density? The density of seawater is a little higher than pure water. The density of seawater is 1.03. So this means 1.03 grams of seawater for every 1 milliliter of seawater. So if you weighed out a milliliter or a cubic centimeter of seawater, it would weigh 1.03 grams, a little higher than pure water. Okay, so this is a relationship here. This can convert grams of seawater to grams of sodium chloride, or grams of sodium chloride to grams of seawater. This is another relationship or conversion. We can go from milliliters of seawater to grams of seawater, or grams of seawater to milliliters of seawater, depending on if we flip it. We can flip this upside down, no problem. Use it there. And so these are conversion factors here in the problem. And so these are, when we get to a fork, we can go, this way or some other way. But unfortunately, we're out of time. I'm not quite finished with chapter 3, so we're going to finish up chapter 3 tomorrow. But are there any questions now? Okay, who's still with us? Actually, how many quiz things did I give you? Okay, I think I only gave you C. I need to do a 2D quiz. I only gave you 2 quizzes? All right, we'll do one more here, just really quick. Just say 3, okay, 3. The last quiz is just tell me you're present or just here. Just say you're here, and then that will be the last quiz. Okay, and then once we're done with that, since no questions, we'll end it here as well. Okay. All right. Well, thanks for sticking out another 6.5 hours of straight lecture, and so we'll see you guys tomorrow. Okay. Okay. Thanks. Bye now. Okay. Thanks, Nicole.